Hello, welcome to Gate Academy Global. My name is Kumar Neeraj Raj and I am your mentor here for the subject Signals and Systems. Here we will be dealing with the analysis of different types of signals and systems in two domains, that are time domain and frequency domain. After the completion of the basics, we will be developing the tools like Fourier series, Fourier transform, Laplace transform, Z transform, etc. And you will be finding a wide range of application of these tools for analysis purposes in different subjects like network analysis, control system, analog electronics, power electronics and so on. That's why the subject is really important. Actually, if you are a student of electronics branch or electrical branch or instrumentation branch, then it is very rare that if you are going through any of your subject and you don't talk about the word systems. And whenever this terms come systems, then the knowledge of this subject signals and system is definitely going to help you. Also, you can consider this subject as an extension of mathematics, and due to the beauty of mathematics, the subject is really interesting. So, we are going to start a very interesting and important subject, that is signals and systems. So, whenever any subject seems difficult to you, it means you don't have interest in that subject, and interest comes only from good basics. If you are really good at the basics, then there is no question that the subject will seem difficult to you. So, our prime target is to focus on the basics. If suppose we are planning to cover this entire syllabus in 100 hours, then we are going to devote at least 40% of that total duration only for the basics. So, let us see what are the basics that are essential to understand properly this subject. So, we will be starting obviously first with the introduction part. So, the first part will be introduction to signals and systems. In this part, we will find that how we can define signals and system in different possible ways, what are the significances, how the systems operate. Then after this topic, we will be confined to the basics of signals only. So, in the basics of signals, we will be starting with types of signals. Types of signals. This topic is somehow different by the classification of signals. It is the types of signals that we commonly encountered. After the types of the signals, we will be dealing with the operations on signals. Operations on signals. In this part, we will be seeing that what are the operations that one can perform on a signal, and what will be the effect of that signal, that operation on a particular signal and its representation. What will be the effect of every operation on area of the signal and so on. The operations will be like amplitude scaling, amplitude reversal, time shifting, time reversal, time scaling and so on. So, we will be seeing how the operations are performed on the signal and what are their effects on signal and its representation. After operation on signals, we will be dealing with the basics of, in the basics of signals, we will be dealing with classification of signals. We classify signals on different bases. The basis will be like even and odd signals, how we define even signals, what are odd signals, what are their properties. Similarly, the other basis will be periodic and aperiodic signals, how we judge that the particular signal is periodic or not. If a signal is found to be periodic, then what is its time period, what is its frequency, what is the phase angle and so on. So, classification will be on different bases. The next basis will be energy and power signal, that is very much important. Suppose it is a system, that it is a system and you are applying a particular input and particular output. Whenever in any subject, whenever you talk about a system, then you specify a particular input and a particular output, and these input and output are nothing but signals. So, whenever we are trying to find output of any particular system, then you must have to know that what kind of input are you applying, then only you can predict that what will be the type of the output that is going to be obtained. So, if you know that the input that you are applying is periodic, then this system will perform some operation on the signal and the output will be obtained. So, classification contains types of the signals like we have said, even and odd signals, periodic and aperiodic signals, then energy and power signals, causal, non-causal, anti-causal signals. These will be different types of different bases, and we will classify signals on those basics. Now, after these are what we have written here. It is for the basics of signals. After the completion of basics of the signals, we will be dealing with the basics of systems, and in basics of system we will be starting with classification, or you can also say properties of systems. So, the classification of the system is done by observing the output input relationship. Suppose we are applying input x of t and obtaining output y of t. Then the relation between these input and output will define the properties of the system. The properties are, namely, we will see here the different type of properties like static and dynamic system. If a system, if the present output of any system depends only on present input, then the system will be called as static system. So, there will be again different bases on which we will classify the system, and here we will see the properties like static and dynamic, causal, non-causal, anti-causal, linear system, non-linear systems, time variant, time invariant systems, stable, unstable systems, random system, that is stochastic system or deterministic system, and so on. So, there will be different type of classification. After classification, here we will classify signals on two bases, that are linear and non-linear system and time variant and invariant system. Suppose a system follows both of the properties. If a system is linear as well as time invariant, then the system is called as linear time invariant system, and we represent that system symbolically as LTI systems. These LTI systems, this word LTI stands for linear time invariant system. So, if a system is linear as well as time invariant, then it is called as linear time invariant system. In the basics of classification, we will see that how we can say a particular system is causal or not, we can say how we can say that particular system is stable or not. So, here we will be dealing with particularly with LTI systems, and we will see the properties of LTI system, how we can find output of LTI system for any particular given input. So, this will be discussed in the topic LTI systems, how we can say a particular LTI system is causal, when we will say particular LTI system is stable, when we will say particular LTI system is static, and to find output of any LTI system, we will be dealing here with convolution. It is the tool by which we can obtain output of any LTI system only in time domain. It is the only tool to find output of the LTI system in time domain. Other tools, that is other tools, Fourier transform or Laplace transform, will give you the output of LTI system but in frequency domain. Then you will have to take its inverse transform to find the output in time domain. But if you use convolution, and if you know what is the input that you are applying and what is the impulse response of the system, we will be defining the impulse response. What is impulse response, we will be seeing it. But if you understand, if you have knowledge about the input and impulse response of the system, then you can predict output of any LTI system for any given input. It will be given by the process convolution. In classification, one more basis of classification will be analog and discrete signals, continuous time signals and discrete time signals. So, after the classification, whatever we will be discussing for both, for continuous time signals as well as for discrete time signals. Like if we will be dealing with the operation on signals, then simultaneously we will be performing same operations, once on continuous time signal and once on discrete time signal. After LTI system and convolution, one more thing in the basics we will cover here is eigenfunction and eigenvalues. These are defined only for LTI system. Here we will see which kind of function or which kind of input is said to be an eigenfunction for a particular LTI system, and for every eigenfunction we will find a particular eigenvalue corresponding to that eigenfunction. So, it is very much important, because in the subjects other than signals and system, where you talk about systems, mostly the systems are LTI systems. Therefore, the discussion here that we are going to discuss will definitely help you to solve problems of convolution, problems of communication, network and control. So, the system here we have discussed, we have written only for the basic part. In the basics we are going to cover at least this much portion, and many things I am skipping here to write, but that is in between the lines, you will have to read between the lines. We will have discussed more problems, and what important thing is, as we have discussed earlier, that we are going to give our 40% of total time duration only to these basics. These are, it seems that it is a small portion, but you will find that it is going to take a lot of time to complete this much portion. But once if you are comfortable with this much thing, then there is absolutely no problem with the other things that we are going to study in further chapters. So it is the foundation, and the foundation decides that how strong is the building is going to be. So you have to focus on this part, and our prime target is to develop a problem solving skill in your. Therefore, we are planning to discuss here at least 600 to 700 questions from all competitive examinations and from other sources also, so that it's my duty to impart confidence in you. Confidence such that if any problems comes in front of you, then your first attempt must be full of confidence. So if we will be practicing more and more problems, then there will be more and more confidence you will be gaining. So we are going to discuss here at least 600 questions. You can mark this word. So let us start. To start with, we are just starting the syllabus with introduction to signals and systems. So to start with, here we are taking this topic, introduction. Introduction, if we talk about signal, then we are already familiar with this term signal, but probably we have discussed this signal term in our lower classes also, but we used the term signal, instead of signal we use the term function. As in 10th or 12th class, you must be studied the function. Like if we have written a function f of x, y, function y that is function of x is given as suppose x square plus 2. So if you have to plot the graph of the signal or function y is equals to x square plus 2, then what you do is, here you take the values of x and here you take the corresponding values of y, that is x square plus 2. If you put 0, then y is equals to 2. If you take 1, then 3. If you take 2, then 6, and so on. So what you do here to plot the graph, here it is the x axis and here it is y, that is function of x, and you plot the graph. At x is equals to 0, function is 2. At x is equals to 1, function is 3. At x is equals to 2, function is 6. Here something. So you will get something like this. It is the plot 2, 3, 6, and so on. So this is the only thing that we are going to discuss here. So what are the signals? Signals you can define in easy way, that anything that contains information, any physical quantity that contains information or any physical quantity that is used to convey information is called as signal. As you are watching me or you are listening to me, it is only possible due to the signals. You are getting signals in voice and in picture form, therefore you are getting my points. So the process of conveying the information through the functions, which functions conveys the information are called as signals. So basic difference between signal and function, what is the difference between signal and function? The only one difference, signal is, there are two types of functions. One are single valued and other is multiple valued. So signal is a single valued function. It is a single valued function. What does it mean by single valued function? It means, like here we can say, if x is equals to 0, then y is having only one value, that is 2. If x is equals to 1, then again y is having only one value, that is 3. If x is equals to 2, then again y is having only one value, that is 6. But if you plot something like this, if a function is like this, suppose it is function x, it is f of x. Now let here we can say, here it is a point x is equals to 2. So at x is equals to 2, y is having two values, one is plus 2 and one is minus 2. So it is the function that, but it is a multiple valued function. So signal must be a single valued function. If a function is having more than one value at one instant of time, then it is not a signal. It is important to be noted. So signal, how we define the signal? We have said signal is a physical quantity that contains information, correct? But mathematically, signals are defined as function of one or more independent variable. Signals are mathematically expressed as function of one or more independent variable. Usually the independent variable is time. Now here are 2 points here, one or more independent variable. At first we can see variables. Whenever you talk about variables, there are 2 types of variables. One is dependent variable and other is independent variable. Whenever you talk variables by the name suggests anything that is varying. If the thing is varying, if a quantity is varying, then it is called as variable. So if we talk about independent and dependent variables, let us consider a function of time f of t, that is t square plus 2. So this function depends on time. So it is a variable, and it is which kind of variable? It is a dependent variable, as the value of f of t is dependent on the value of t. How? As you will going to change t, then the value of f of t will be changing. So f of t is a variable and it is a dependent variable. Now if we talk about time, time is varying every second, but the variation of time doesn't depend on anything other. So time is also a variable, but which kind of variable it is? It is an independent variable. So here we have written that mathematically we can express the signal as a function of one or more independent variables. So we are going to express signals mathematically by independent variables functions, okay. So if independent variable, and usually that independent variable is going to be time. So we will be representing the signal with respect to time. Now what does it mean, one or more independent variable? If a function is, if the signal is function of only one variable, then it is called as one dimensional signal. If the signal is function of more than one variable, then it is called as multi-dimensional signal. Like you talk about video signals, then it is a 3-dimensional signal. If you talk about picture signal, it is a 2-dimensional signal. But fortunately, what you have to study in the syllabus, that is, you only have to study one-dimensional signals. One-dimensional signals, that is, the signal will be the function of only one variable, one independent variable, and normally this independent variable is going to be time. So what you have to do? You have to express mathematically signal as a function of time only, like we have written, suppose x of t is equals to t square. So now it is x of t is function of time only, therefore it is one dimensional signal, and as the time will be changing, so the value of x of t will be changing. According to this rule, x of t is equals to t square. So it is the definition of the signal, that how you can define signal, what signal represents, why signals are used. Signals are used to convey information, okay. Now if you talk about the signal systems, so now if we have to define system, let it is a system. In different subjects, you find different examples, different definitions of signals, systems. Like in control systems, you define systems as, system are interconnection of different physical components which is used, different physical components which acts together as an entire unit to perform certain objective. That means a system will be interconnection of different physical things, like this fan. This fan contains several things, but it is acting as an entire unit. It is acting as a unit. You don't talk about there are blades, if one asks that what is this, then you call it is a fan. You don't say that there is a blade, there is a motor, not. You only say that it is a fan, and why we are using it? Because we want to get air from it. So system is interconnection of different physical components which is used to perform certain objective. Which is used to perform certain objective means you will apply particular input and you will get your desired output. So, but in signals and systems, you define systems in only one way. System is interconnection of different physical components which is used to convert one form of signal into other. If it is a signal, if it is a system, then you will be exciting it. Here you will apply excitation, and whenever you will be exciting a system with any particular excitation, then for every excitation a system will respond and therefore it will produce a response. This excitation word is used as input in signals or different subjects, and this response is known as output. The output and input is related by the operation which the system is going to perform. Like what we have said here, that system is interconnection of different physical components which is used to convert one form of signal into other form. Suppose here we are applying input of signal 1, here we are applying input signal 1, and this system converts this signal 1 into another form, that is signal 2. So here is the system which is used to convert one form of signal into other form. The operation that the system perform is normally represented by T operator. Here it is T. Like we can say, if output you are representing output with y of t and input with x of t, then you can say that this output y of t will be obtained when this operation, this T operation is performed on which? On this input. This T operation may be anything. Like if you say that here the T operation is to square of the input. Let you are applying input x of t and you are obtaining the output y of t. So what this operation means? Whatever will be the output, whatever will be the input you are applying, the output will be square of that particular input. Therefore you can write here y of t is equals to x of t whole square. So it is the operation that the system is performing on the input to generate other signal. So what is the system? It is interconnection of different physical components which is used to convert one form of signal into other form, like here it is performing. So the operation can be anything. The system can be a differentiator, then this T operation will be represented by d by dt. The system can be an integrator, then this T operation will be represented by integration from minus infinity to t. So other different system will have different operations performing on inputs to generate output. So till now we just have introduced the subject and introduced the basics that we are going to cover first. These are the basics. Maybe possible some points I have skipped because I just want to focus on the main parts, but these are the basics and it will take a lot of time. But as I said earlier, I told you that all the basics will be deciding that how much strong your subject is. So focus on these basics, be regular in studies, and feel free to comment if you are facing any kind of difficulty, if you are not getting my points, or if you have any problem with my communication skills, then you definitely have to tell it in comment section so that I can act accordingly. And what I have to do is to clarify all the topics in systematic manner, because if you interconnect the things, if you can interconnect the topics that you are going to study with the topics that you have just studied previously, then the concept that you will be getting will be far better, and the confidence you will be getting will also be so strong. So now I am ending this lecture here, and from the next lecture, now we will be confined on the basics of the signals, and we will be defining what are the different types of the signals, what operations we will be performing on a signal, and what will be their effects, and the classification of the signals. These will be the next topic, and I am sure we will be enjoying to get together. It is a new experience for me, and still I have experience on GATE Academy channel, and you have really appreciated that lecture. So I am really confident that we will be getting bigger goals this time in English, but still it is new thing. So I really want your cooperation, and with time I will be getting better and we will be enjoying this. Thank you so much and all the best.